Okay, this is question 10 from the P1 paper, June 2022. And as we get into it, you'll see that this is differentiation. It's going to be working with gradients, tangents, and normals. Let's have a look at the question then and see what we've got. It says the sketch of C is a cubic there. Yeah, I can see it's a cubic. It's got a maximum and minimum. But where K is a constant, that's going to be important in a minute. They don't tell me all of the equation for C. It says find dy by dx. I'll be able to do that. I'll do that in a second. Let's just read on to the rest of it. It says the line L, this is an interesting line. This line L then is going to be a normal for A. Okay, so that's cutting at 90 degrees there, but it also cuts the curve here at B, and it's a tangent at that point. So I've got a choice. I might be working out equation of a tangent or equation of a normal. And it says, show that the x coordinate of point B is a solution of the equation, that thing there. Okay, let's get started and find dy by dx, and I'll explain what we're going to do for part B, because dy by dx is relatively straightforward. So A, we've got y equals 2 over 7 x cubed plus 1 over 7x squared minus 5x over 2, but then this plus k. Well, that's not going to have any problems for my differentiating. That's fine. Differentiating, we multiply by power, take one off the power, so that's going to be 6 over 7 x squared. Same thing again, we multiply by the power, take one off the power, that's going to be x, and then obviously just minus 5 over 2, and the k just disappears. So my gradient function, my dy by dx, no problem with that. It's just done there. Now let's go back and look at the other part of this question. I might make it a bit smaller just to see the question. So what it says is we're trying to work out B. We're trying to work out this point here. So normally what I would do, I thought I had it right to start off with, is let's just work out the equation of the normal, and then if I put the equation of the normal equal to the curve, that's fine. I'll be able to work out what B is going to be. Unfortunately, we can't do that, because if I try and put it equal to the equation of the curve, I'm going to have that K in there, which is going to cause me a problem. So an alternative method, and the method that we're going to use, is what we're going to do, because we know A is the point with x coordinate being minus 7 over 2 here, what I can actually do is work out the gradient of the normal at A. Now that gradient stays as being the same gradient when it comes down here and clips the graph at B and just cuts the graph at B there. So what I'm going to do is I'm going to somehow work out what the gradient of the normal is. I'll be able to do that. Once I've got that, I'm going to say that's the same as the gradient of the tangent at B. So I'll be able to use that to form some sort of equation. Right, so I've told you what I'm doing. Now what I've actually got to do is to tell the examiner. So for part B, let's first of all actually work out what the normal is going to be, the gradient of the normal. So x equals minus 7 over 2. dy by dx is going to be, put 7 over 2 in, and be really clear as to what you're doing here for the examiner. Minus 7 over 2 there, minus 5 over 2. You can stick that all in the calculator and work it all out. I've already done it. It works out that the gradient at the point minus 7 over 2 is 7. That's telling me that the gradient 7 going in that direction, the gradient of the tangent, I actually want the gradient of the normal, so I'm going to say that. The gradient of the normal then will be minus 1 over that, so will be minus 1 over 7. So that's the gradient of the normal at x equals minus 7 over 2. So that gradient is then going to be the same gradient, the gradient here of minus 1 over 7 is the same as the gradient there, which is now the gradient of the tangent. So I'm going to just make that clear then. So the gradient of the tangent at B is also equal to minus 1 over 7. Well, the gradient of the tangent, that's dy by dx. So in other words, dy by dx, sorry, handwriting, dy by dx, which I've already got, 6x squared over 7 plus 2x over 7 minus 5 over 2, that is equal to minus 1 over 7. Right, so now I'm quite happy. Hopefully, multiplying all this out and tidying it up will get to be the equation that they said here. Hopefully that's going to work out to be that, but let's go ahead and do it. Right, that looks horrible, so just multiply everything through by 7. Or you can actually, if you want to, multiply everything through by 14, all in the first instance. It's entirely up to you. Yeah, I think I'm going to do that actually. Let's just multiply everything by 14. So I get 2 lots of 6x squared, that's 12x squared. 2 lots of 2x, that's 4x. 7 lots of 5, that's 35, is equal to minus 2, which then is 12x squared plus 4x minus 33 equals 0. Please, please, please. Yeah, that works out to be, sorry, I did that a bit quick. That's working out to be equal to that bit. Okay, so the way that we did that, just a recap, was we said the gradient here is going to be equal to dy by dx. The gradient there is the same as the gradient at A, and the gradient at A is the gradient of the normal there, is the same as the gradient of the tangent there. Quite an unusual question, so hopefully it makes sense to you as we're doing that. So we've done part B. What does part C say? Part C says, hence find the x coordinate of B. Okay, that means solving that equation. Oh, I forgot. So part C, we've got the equation 12x squared plus 4x minus 33 equals 0. And I've just got to solve that. Just get good at factorising. This is a GCSE skill. I'm not going to do it in this video, but it really is useful to you. I know some of you use your calculators for doing this sort of thing. Very, very helpful if you can factorise any sort of quadratic that we're given here. That factorises out to that, which gives me 2x minus 3 equals 0, or 6x plus 11 equals 0. That's going to give me x equals 3 over 2. That's going to give me x equals minus 11 over 6. And I did notice something, what did it say in the question? Justifying your answer. Yeah, if we go back and have a look at that, I can see from the diagram that my answer is going to be the positive x value. Okay, so it's going to be the positive x value. So my x value is that one there. Cannot be negative from the graph. That should be enough to explain to the examiner what I'm doing for that part there. And then part D. Let's go back and have a look at part D. What does part D say? So part D says, given that the y-intercept of L is minus 1, okay, yeah, so I'll just get rid of some of the other bits and pieces off of this graph now, because we don't need them. The y-intercept is going to be minus 1, so that value there is going to be minus 1. Can you find the value of k? Well, what I can do, if you're telling me that the y value there is minus 1, is I can now write down the equation for L. So let's just talk about that. For L, y is equal to mx plus c, so y is equal to, we know the gradient of the line is minus a seventh x, and we actually know the intercept is minus 1. So that gives me that. So if I want to now find point A there, point A is when x equals minus 7 over 2. For point A, x equals minus 7 over 2. So y would equal minus a seventh minus 7 over 2 minus 1. So y would be the point minus a half. So what I've now got are the coordinates of this point. Sorry, keep going back. I now know the coordinates of this point here. It's minus 7 over 2 a half. And if I've got that, I can put that information now into the curve to see what k is going to be. Okay, so I've found the value of a now. So if I say my equation for my graph is y equals 2/7 x cubed plus 1/7 x squared minus 5 over 2 x plus k, but we know when y is equal to minus a half, x is going to be equal to minus 7 over 2 cubed 7 minus 7 over 2 squared minus 7 over 2 plus k, and just rearrange all that. This video is already too long, so I'm not going to spend ages going through and doing that. Hopefully you can calculate all that stuff out. When you do that, k just works out to be equal to minus 5, works out to be equal to 5 over 4. So quite a tough question, but it's question 10, so it's fair enough. It's the last question on the test. Hopefully that makes sense.